Hey, my name is Josh Speyer, founder of the Coherence Report. I'm just checking in here on a Sunday afternoon. Uh, Hope everyone had a great weekend. So last weekend, Nvidia announced the release of its Ising toolkit, which is actually a set of open source AI tools, and they're designed to make quantum computers more reliable and easier to operate. Before we discuss what this does, I just want to make clear here what is not. This announcement from Nvidia last week, it had absolutely nothing to do with quantum AI. All right. Quantum AI refers to the usage of quantum computers to run AI workloads, but it is not referring to the usage of AI to manage a quantum computer. So the difference really is that one is an AI that's being driven by a quantum processor, and the other is just some tool for an engineer to manage the hardware on a QPU. NVIDIA, the toolkit that NVIDIA released called Ising, it has absolutely nothing to do with quantum AI. And the fact that people on social media are saying it does, it just shows how people are spreading misinformation just for clickbait purposes. So with that being said, there is some fascinating things in this release, and I want to talk about those. As always, we're going to go into technical detail, but I'm going to make sure it is very understandable for you. So as a reminder, if you like this level of content, please review our website for more articles. We're going to be posting other videos on here. You'll find everything, no spin, just understandable analysis to get you informed. All right, so let's talk about the release tools. There were two tools that were announced on Wednesday. The first is Ising calibration, and the second is Ising decoding. One of those automates the process of tuning the processor, in other words, keeping it stable. And the other one automates real-time error correction. For today, we're just going to talk for a few minutes about why this is important, what the usage is of AI, and what this really means for the future of quantum computing. All right, so Ising calibration. Calibration refers to the process of tuning the quantum processor, and that's done before it can even run any computation. Every quantum processor behaves slightly differently. Even if it's the same brand of processor, there's always its physical imperfection, there's environmental sensitivity. Remember, we're talking about very, very tiny things, for example, individual atoms. And at that level, the rules of normal physics just don't apply. And so so it becomes very sensitive to things that human beings can't see or even predict. If you don't calibrate it correctly, you end up getting all these random errors, which destroys your computation, which is, or whatever you're trying to do with the quantum processor. Typically, we're going to do calibration at the beginning of the computation, but it also happens during the process of running computation because qubits going to drift over time. So I want to give you guys an analogy here. Think about this like owning a piano. Everyone who's owned one before knows that when a piano goes out of tune over time, just from being played, or the temperature is going to change, or there's any kind of humidity, and then you end up having to pay someone to come in and test each string. And they're adjusting the tension, they're adjusting the tension on everything, just making sure that the note is the exact right frequency. And on a small piano, for my math, there's 88 keys. That takes about an hour or so for someone to go in and configure it. But imagine if that piano had 10,000 strings and every single string affected the string that was right next to it. And then that string, and by the way, you're playing the piano while you're tuning it, right? So, there's all these levels of complication beyond that. And that's the equivalent of what the calibration problems that you have in quantum computing. Now, what Ising does, what the NVIDIA toolkit does, is it replaces a lot of the time-consuming manual process that goes on with that with an AI agent. And so that's going to tune the quantum computer faster and more scalable, replacing a lot of the manual process or some of the stuff that's done by a one-off Python script. That's very different from quantum AI because because the AI that's being used for the toolkit, it's not being run on a quantum computer. It's actually being run on NVIDIA GPUs. All right. Now, the second launch was the Ising decoding. Decoding, we'll define that in a second, but essentially what this has to do is qubit error correction. Qubits are very fragile and they're constantly making these errors. So, and really, if you look at the future of quantum computing, it actually resides in our ability to be able to correct for errors in real time. All right. That's why they call it FTQC. The software that handles all this is called the decoder. Anyone that's interested in learning more about the future of error correction, you want to see the article that we write about 99% on our website. It's a great article. I put a lot of time into writing that and help you understand exactly why these error rates are so important. The way that decoding works right now, though, is you are reading error fingerprints on the qubit. So think about that as just clues that are left behind when an error occurs. What they're doing is they're working backwards to determine what the cause is. What Ising does is it is using an AI model to solve any kind of current issues in the decoding process. And then we're analyzing patterns and how those errors evolve over time. And so in that way, you can scale your qubit usage in a way that you just can't do given current processes. Now, for example, let's think about, I like to give analogies here. Let's think about weather forecasting. A long time ago, weather forecasts would look like, it would look at today's weather and then it would just predict what the weather is for tomorrow. But nowadays in modern forecasting, these guys are looking at how pressure systems are moving across the country, or looking at changes in temperature gradients. You're looking at the direction of wind patterns and seasonality. And this is really what Ising wants to do for quantum computing, is incorporate a lot more of the stuff over time. And it's using an AI model in order to do that. Again, this is very exciting stuff, but it has absolutely nothing to do with quantum AI. And, really the confusion around here, the problem that I see here is that the people in the media, they don't understand, the people that are writing about this, they don't understand press releases in quantum computing. So the average reporter, even if they're a technology reporter, they just see the word AI printed 10 times in the Nvidia announcement. And then they tell everyone that Nvidia just proved that quantum AI is real. The worst culprits out there are the people who do know better. And I'll show you this example here on screen. This guy knows the industry, and people like this should have the responsibility to be truthful. But at the end of the day, these people are all just fishing for clicks, including Alan Barrett's CEO of D-Wave, who clearly got confused by this announcement too, because he used it to talk about D-Wave's quantum AI narrative fiction. All right. So as we've talked about, there's a ton of noise out there. You want to make sure that you come to Coherence Report for real information without the hype. If you're watching this on YouTube, you want to make sure to subscribe, leave us a comment, and I'll personally respond. Our website is coherence.report. Go to Insights for our free articles. We actually have a great article about this Ising announcement and what it actually means for the future of quantum computing. And so I appreciate everyone's time, and thanks for being here.